Hi everybody, I'm Greg Fishel. Welcome to bonus weather video number 1 for this week, and I've entitled this, I hope this doesn't phase you. And it will become apparent to you why I titled it that way in just a second. So put myself down here in the corner and we're going to talk about the 6 different phase changes that can occur with respect to water. The first one is going from solid to liquid, which of course is melting. That absorbs heat from the air and the result is cooling. And don't worry about the units there, but the number is important, 334, when we compare it to other processes. Now, when we go from liquid to vapor, that's called evaporation. That also absorbs heat from the air, but at a much, much greater rate. And so evaporation is going to cause considerably more cooling than melting will, but melting will still cause some. And then in some cases, you can go straight from solid to vapor, which is called sublimation. So if you have snow on the ground and it actually doesn't melt, it just, in a sense, goes straight to the vapor state, then that's called sublimation, and that absorbs heat from the air, and the rate at which it does it is the sum of the total of those two other processes, melting and evaporation. Now, going the other direction, vapor to liquid is called condensation. That releases heat to the air at a pretty good rate. Going from liquid to solid, of course, is freezing. That also releases heat to the air, which results in warming. And then if you go straight from vapor to solid, that's called deposition. And again, that produces warming. Now, looking at this graphically, here we are going from an ice cube, or snow, if you will, to liquids. So it's melting, and that melting process is actually cooling the air. Sounds counterintuitive, right? Evaporation absorbs heat from the air, which results in cooling. So if you have liquid falling into dry air, okay, then that evaporation process produces cooling, and you can see that really at all times of the year. But think about in the summer when you've got a hot, humid air mass over you, and even though it's humid, the relative humidity when it's 95 degrees may be 40%. So you drop raindrops into that relatively dry air and you get lots and lots of evaporational cooling, and all of a sudden you're sitting at 75, and it's all happened because of that process. And then if you go straight from solid to vapor, that's called sublimation, and again that causes cooling. So you can have snow that actually goes straight to the vapor state and doesn't actually melt, and again that is called sublimation. Now on the other side of the fence, when you go from vapor to liquid, condensation actually releases heat to the air, which results in warming, and freezing also releases heat to the air, which results in warming, but not as nearly the clip that condensation does. And then if you go straight from vapor to solid, that means that that's called deposition, and that also results in warming. So looking at a summary here of what I call counterintuitive thermodynamics, melting snowflakes result in cooling, okay? So imagine a situation where it's above freezing at the ground and it's snowing very, very hard. Well, all those snowflakes, when they melt, when they hit the warm ground, that causes cooling. And if you have a whole bunch of snowflakes melting at the same time, you get a fair amount of cooling, and then all of a sudden the ground temperature cools enough so that the snowflakes can start accumulating, okay? So you'll see that, again, when the ground temperature is above freezing, but it's snowing very, very hard. Now, raindrops evaporating into dry air cause cooling, and we've already talked about an example of that with a thunderstorm. Water vapor condensing into raindrops causes warming, okay? So you can actually, at whatever level the condensation is occurring at, the air temperature will actually go up as a result of that process. And finally, rain freezing into ice pellets, or sleet if you will, or on contact with the ground causes warming. And this is why freezing rain is described as a self-limiting process, because the ground is cold, the rain falls onto that cold ground and freezes on contact, okay? But that process actually results in warming, okay? And so as a result of that, the air starts to warm. And so this process of freezing can only go on so long before the temperature will eventually get up to 32, unless you have a reinforcement process going on. And this is what we talked about with the last storm, where we didn't have the big high sitting off to the north to continue to send cold air reinforcements in. So this process can be compensated for, if you will, by cold air advection, okay, cold air being funneled into the area via a wind, mainly from the north or northeast. But if there's not that going on, then eventually the temperature will get up to the freezing mark and then just sort of hold there until something else comes along to make it change. All right, that is it. Oops, blank slide. That is bonus weather video number 1 for this week. I hope you found that somewhat interesting. The next bonus video will be Wednesday. The next daily update, of course, coming up tomorrow. I hope you have a great Monday evening, and we'll talk to you soon. See you later.